Hello friends, so in today's question, we are going to find out whether the blocks will be moved together or not, and we are also going to find out their respective acceleration. So this is the wall and the blocks are being pressed against this wall by the force of 30 Newton, and we have coefficient of friction at this point is 0.5 and there is no friction between the 2 kg block and the wall. Okay, so this is our wall, so that's why it is written as 0. So we are going to have the forces which will be acting. We have mg in the downward direction. Okay, so that will be 20 Newton, and in this case also we have mg in the downward direction, and that will be about 10 Newton. And we have a force that's being applied of 30 Newton. Therefore, this will result in a normal at here, and we can say that normal will be equal to, let me write it here, normal will be also equal to 30 Newton. Okay, at this point. And we can find out the maximum value of the friction in between 2 and 1 kg block. Okay. So we can say that F1 max will be equal to, we have a 30 normal and multiply by 0.5, so this will be giving us a 15 Newton maximum friction that will be acting between 1 kg and 2 kg block. So now we can just make this a horizontal system, which basically means now this is the wall and we have 2 kg system block, and this is our 1 kg block. Okay, and we are 1 kg is, there is a 10 Newton force, and for 2 kg there is a force of 20 Newton, and at this point we have a friction force F1 max which is given as 15 Newton. So this vertical system is being converted into a horizontal system, and then we can solve it just in a normal way. Okay. So what we do, we assume that there is no friction between 2 kg and 1 kg and find out the respective acceleration. Okay. So we assume no friction between 1 kg and 2 kg blocks. So we can find out that acceleration of 1 kg will be equal to 10 meter per second square, and acceleration of 2 kg will be also equal to, because force is 20 Newton, so this will be also coming as 10 meter per second square. So both blocks have same acceleration, basically, which means a 1 kg is equal to a 2 kg, or this can be also concluded that there is no relative motion between the two. So there is no relative motion between the two, and we can also say that they will be moving together. Okay. Therefore, they will move together with an acceleration of of 10 meter per second square. So this was the simplest one. Now we take a little bit slight modified version of it. So we have two blocks once again, 2 kg and 1 kg. Now the force is 40 Newton. Okay, the force is 40 Newton, and the coefficient of friction between 1 and 2 is given as 0.4, and between the wall and 2 kg is given as 0.2. Okay. So once again there will be 20 Newton in the downward direction, and this will be having a 10 Newton. Okay, and the normal in this case will be of 40 Newton, because 40 Newton force, external force, is being applied. We can say that normal will be of 40 Newton. So we can find out the friction between 0.4 and 1 kg and 2 kg. Okay, let us call this as F1 max. F1 max, that is frictional force between 1 kg and 2 kg. This will be equal to 0.4 into 40. Okay, 40, sorry. So this will be coming as 16 Newton. And similarly, we find out F2 max, which is the F2 max frictional force between 2 kg and wall. This will come equal to as, we have 0.2 and multiply by 40, and this will be giving us 8 Newton. So once again we are going to convert this vertical into the horizontal one. So this will be our ground now, and we have 2 kg, one kg force is 10 Newton, and 2 kg is 20 Newton, and the force, frictional force in between, is given as 16 Newton, and here it is given as 8 Newton. So once again we are going to assume that there is no friction between 1 and 2. Okay. So you can say, assuming no friction between 1 kg and 2 kg. So we find out the individual acceleration. A 1 kg, acceleration of 1 kg is over 10 meter per second square, and acceleration of 2 kg is coming as, for 2 kg there is a force of friction. Okay, so we can say 20 minus 8 and divided by 2. So this will be coming as 12/2 or 6 meter per second square. So if you make comparison between acceleration of 1 kg and acceleration of 2 kg, so we can clearly see that acceleration of 1 kg is greater than acceleration of 2 kg. So from here we can say that if we draw respective forces which will be acting because of the motion, this is our 1 kg block and this is our 2 kg block. Okay, so acceleration of 1 kg is greater than acceleration of 2 kg. So because of that, the 1 kg will try to move 2 kg towards the right side. Okay, so this will be FR1, and accordingly there will be a force which will be acting here, FR1. Okay, and they are moving in this direction. The force is acting in this direction. So one of the main reasons of assuming that there is no friction between 1 kg and 2 kg, we can make the comparison between the acceleration of one body to another body, which helps in finding out in which direction the force will be acting. Okay, so if acceleration of 2 kg is greater than 1 kg, then 2 kg will try to force 1 kg, so the force will be acting in this direction, and correspondingly because of 1 kg and 2 kg, force will be acting in this direction. So this is a very important step here, that we assume there is no friction, find out the respective individual acceleration, make the comparison, and this will be helping us in order to find out in which direction the respective forces will be acting. Okay. So we can say, therefore, therefore 1 kg block will try to move 2 kg block towards right. We try to move 2 kg block towards right. And now we can just solve it normal way. Now we already know the directions, everything. Okay, so now we assume that both are moving together. Okay, assuming both blocks are moving together. So if both blocks are moving together, so we can say there will be weight of 3 kg. Okay, and we have a combined force of 10 plus 2, and there will be friction here of 8 Newton. Another thing, there will be also individual forces. Here will be 10 Newton, and here will be of 20 Newton, and there will be a friction force here, that is FR2. Okay, that is obvious here, it's not a big issue. So if they are moving together, and let us say they are moving with the A acceleration in this direction, so we can find out that A, or 3 times A, is equal to 30 minus 8. From here we can say that A will be coming as equal to 22 divided by 3 meter per second square. So this is the combined acceleration for both the blocks. Now we are going to analyze the individual blocks. Okay, you can say that for block 1 kg. So we have this our 1 kg block, and we have force of here 10 Newton, and we have our FR1 this direction, and acceleration we already found out that it's 22/3. You can see that 10 minus FR1 will be equal to 1 into 22/3. From here we find out what is our FR1. So FR1 will be coming equal to as 10 minus 22/3, and this will be coming as 30, and 30 minus 22/3. So FR1 is equal to 8/3 Newton. And we already found out that the maximum friction FR1 is 16 Newton. Okay, FR1 max we already found out is given as 16 Newton. Okay. So if you make comparison, you can see that required FR1 is less than the maximum value of the friction. Okay, the required value is less than the maximum value. So it means no slipping will be no slipping. If no slipping is going to take place, then blocks 1 kg and 2 kg, blocks 1 kg and 2 kg will move together with an acceleration of 22/3 meter per second square. So there is not much of the difference between the questions which are given in the horizontal form and the vertical form. We simply find out the various forces first of all in the vertical form, and then convert it into horizontal form and solve it in a more traditional way. This is an easiest way to solve it. Thank you. So this is the third question. Determine the magnitude of frictional force and the acceleration of the block in each of the following 3 cases. So there are 3 cases, and we are supposed to find out what will be the magnitude of frictional force and the acceleration of the block in each of the following cases. So let us consider first of all case 1. Okay. For case 1, so we have a 5 kg, and the force that is being applied to it is 100 Newton. And in this case there are 2 friction given, static and coefficient friction, static and kinetic. Okay, so first of all we can clearly see that there will be a 50 Newton force acting in a downward direction. Okay, and the normal, okay, and the normal will be of 100 Newton. 100 Newton. So let us find out what will be our, because there are 2 frictions, so let us find out the respective values. So Fs max will be equal to, static is given as 0.4, and into 100, this will be giving us 40 Newton. And F for kinetic, whose value is given as 0.3 into 100, and this will be coming as 30 Newton. So let us make it a horizontal one. So we have, this is 5 kg, okay, and this is a force acting of 50 in this direction. So we have Fs max as 40 Newton, and for kinetic it is 30 Newton. From, let me write it here, we have, so we can clearly see that the applied force, that is of 50 Newton, okay, the driving force rather, okay, the driving force will be nothing but mg. We can see applied force or driving force is greater than maximum static friction, okay, greater than maximum static friction, okay. So let us denote this force as F. So we can see that F is greater than Fs max. So it's quite obvious now this 5 kg block will be in motion, okay. This implies that 5 kg block will not be at rest, okay, it will try to accelerate towards left side, towards left, okay. So toward left basically means in the downward direction, or left means downward. So we say that if A is the acceleration, so we can find out A will be equal to, that is 50 minus, now this will be kinetic friction, that is 30 divided by 5 kg. This will be giving us 4 meter per second square. Okay. So acceleration will be 4 meter per second square, and the friction, magnitude of frictional force, that is will be Fk, will be given as 30 Newton. So this is case 1. Okay, in case 2, now it is 5 kg, but now the force is given as 500 Newton. Let us call this as F. So in the downward direction we are going to have 50 Newton, okay, and once again the value of maximum kinetic and static friction will be, okay, so we can say normal in this case will be our 500. So we can find out our Fs maximum will be equal to, the static coefficient is 0.4 into 500, and this will be giving us 200 Newton, and for kinetic maximum, in case value is given at 0.3 into 500, this will be coming as 150 Newton. So once again, we are going to make it as the horizontal direction. So this is our block, 5 kg. The driving force is 50 Newton. Sorry, it should not be F, but this will be F. Okay, yeah, and let us suppose it is moving with the acceleration A. So the driving force is 500 Newton and the static is 200 Newton. Okay, so once again, the driving force that is F is greater than maximum static friction. Now we can see F is greater than my mistake, this is 50 Newton. Okay, you can see the driving force F is less than the maximum static friction. So it means F is less than Fs max. So under this condition, the block will not move. See, that block will not move. Therefore, acceleration will be 0. And next we are going to find out the magnitude of frictional force. Okay, so magnitude of the frictional force will be nothing but value of the driving force. Magnitude of frictional force will be equal to driving force, that is 50 Newton. And case 3, now the force is being applied at an angle of 37 degree with respect to horizontal. So this now weight is 12 kg and this is horizontal and the force is being applied at an angle of 37 degree and force is 500 Newton, sorry, and the friction are same. So once again, okay, now in this case we can divide this force into two components, this and the horizontal one. Okay, so we get this as 500 sine of 37 and this will be 500 cos of 37. So sine of 37 is going to give us 300 and this will be giving us 400. And we have 120 mg in the downward direction. So in this case the normal will be over 400 Newton, and so we can find out our F static max static coefficient is given as 0.3 into 400, and this will be our static is 0.4, sorry, this will be 160 Newton, and kinetic maximum will be 0.3 into 400, this will be giving us 120. So now we can make it a simple block of 12 kg, okay, and it will be having a force of so there will be now two forces acting, okay. So if you rotate it in this way, we get 300, okay, and we have here as 400, and rest are same, yeah. So now we can say that the driving force because there will be a force of friction also, which is given as 160, 120, yeah, okay, 120 and 160, let me check, yeah, 120 and 160, okay. So we have a driving force that will be equal to 300 minus 120 yeah, this is 120. So we have driving force of 300 minus 120, this will be equal to 180 Newton, okay, and we can clearly see that this driving force is greater than our Fs max. So we can find out our acceleration. Acceleration A will be equal to 180 minus 120 divided by 12, and this will be giving us 5 meter per second square. Okay. And this will be in the upward direction. Okay, because A will be in this direction, so if you rotate it, this will be coming in upward direction. Okay. And the maximum we are going to find out also the frictional force. Okay. This force of friction will be equal to our kinetic, that is equal to 120 Newton. So this completes the question. Once again, we can clearly see that the vertical can be simply converted into horizontal part, and the only difference will be lie, or we can say we have to be more cautious when finding out the directions. If the magnitude is required, magnitude is quite easy to find out, but if you want to find out the direction as well, So we have to more cautious, because in this case we can say it will be acceleration upward direction, and in the other cases, first case, it will be in the downward direction. So we have to be more cautious whenever we are going to find out, especially the direction. Magnitude we can find out quite easily. Magnitude is not a big problem. Thank you.